Hi, Tim.
Hi, Kenneth. So everyone, it gives me great pleasure to introduce Kenneth Ang with Terra Remote Sensing. So we are truly coast to coast today, with me being in Nova Scotia, and I'm not sure, Kenneth. I think that's just a screen behind you, but
Yeah,
maybe it's the Pacific Ocean as well. And obviously, you're located in the beautiful British Columbia, and very much look forward to your talk today about looking at wildfires in Lidar. Very, very timely and important topic. So, Kenneth, I'll pass the floor to you.
thank you so much, Tim. So my name is Kenneth Ang, and I work for Terra Remote Sensing. I'm project manager and Geomatics lead, and I primarily take care of the UAV program here at Terra. It's a very new program, so very exciting to be leading it. But today we'll be talking about our other work with our helicopter systems and all that stuff. So today we'll be talking about who Terra Remote Sensing is, the four applications of wildfire mapping, fire surrounds the Bellows, BC, and Cameron Lakes. Highway 4 wildfire, sponsored by we did this for the BCMOTI, basically the highways. And these two will be case studies around post-wildfire mapping and activities around that as well. And finally, we'll discuss why is this important. So who is Terra Remote Sensing? We are a Canadian remote sensing company with offices in BC and USA. And we fluctuate between 80 to 100 employees depending on the seasons. Worked in every continent in over 20 countries, and we have been working with LiDAR since 1985. And that was way before real commercial applications. So we conduct projects in both terrestrial and marine environments, and we have a marine unit arm as well. And our terrestrial arm is mainly helicopter rotary wing platforms. Lately, UAV platforms, it's a very new department here. And what we really bring to the table here in the market is our focus on integration of high resolution multi-sensors for data acquisition, data fusion. So what that means is we are able to take ground data sets from our LiDAR systems, from the marine systems, any sort of terrestrial laser scan or ground surveys, and fuse them all together into one big data set and one comprehensive data set for our clients to analyze, use, and whatnot. So that's our real niche there, apart from being able to really understand what LiDAR is. So where have we worked before? We've basically mapped 10% of all BC with LiDAR imagery data since our inception here. And we do a whole bunch of, we cater to a whole bunch of industry sectors here. So forestry, you can see large format mapping, the Kootenays. We basically covered all of Vancouver Island. And also through our work here, we do a lot of highway and corridor mapping for highways and power line surveys and pipelines and all that stuff too. And a lot of First Nation coastal monitoring and working together with a lot of First Nations for their own mapping projects. And then that's just BC and Alberta, which is and we also have a US presence, and which is south of our border. And that operations ongoing work there covers Washington, Idaho, Montana, Nevada, Utah, and sometimes Northern California. So we're really spread out throughout the Pacific Northwest or the western side of North America. So primarily based in Victoria, BC, and with a satellite office in Portland, Oregon. All right, so moving on to the four types of wildfire mapping here. First up, we got the pre-fire mapping. That's looking at risk assessments and determining what is around the area that could potentially fuel a fire with the amount of logs around that present. Is there a lot of buildings around there that are wood and would help the fire grow? Are there fire breaks around there? Analyze all that stuff. How how healthy the trees are in that area. So maybe we're talking NIR imagery and all that stuff. And so that's a pre-fire. And you can fly these things anytime, any day, just before the fire hits, whenever that happens. And then you got the during fire. This is the real stuff here, right? Where you've got active fire and it's moving rapidly, and what is it doing? So the day-to-day changes from there, how fast the front line is moving, what's burned, what's not. And then once that's kind of fizzles out, you've got the hotspot mapping. So that's coming in with a thermal camera or imagery sensor and kind of pinpointing where the hotspots are so that firefighters or first responders can go in and douse the fires and make sure that it doesn't resurface again. So that's during the fire. And then the immediate post-fire, that's where we'll be mostly concentrating today's presentation on. It's the damage and safety assessment of an area. So what are we looking at there? Structure loss, risk from firefighting activities. So like intense water applications. And when there's a fire, we all know that water bombers come in and just douse the area of water in an effort to really contain the fire there, right? So structure loss, risk from fire activities. So through that, we'll look at two case studies later on in the Cameron Lakes and Zeballos. And then we get into the long-term post-fire. And that's looking primarily at vegetation regeneration assessment. So, and determining how safe the area is after the fire and how do we make it safe again, really. So through trees, you can grow trees and make sure the slope's stable, and also what kind of fire is this are there again? Is the fire going to come in through there again? What kind of fuel loads are present? So this really constitutes a feedback loop here. So after your long-term post-fire can actually blend into pre-fire again for like preventative measures here. So our first case study is Zeballos, BC, and this is a small community on the west coast of Vancouver Island. We work very closely with the First Nations around there, so they invited us over there to do a whole bunch of surveys to help them understand what's going on their nation, basically. So you can see here that this is a RGB. This is primarily pre-fire assessments. So we collected a lot of data over Zeballos in 2015, and this is the RGB imagery here. You can see the town just in the center there and the estuary. And I'd like to bring your attention to the mountain east of the town there. You can see it's all forested. And somewhere in 2018, 2019, a fire hit that mountain. So this is the data set that we collected in 2021. And you can see that mountain pretty much bare vegetation in lots of spots here. So what does this mean for the town, right? Like there are a lot of implications that instantly come to your mind. If there's no trees in there, how stable is the slope? What safety impact is there on the town there? Can the town still be able to function as a town, or do we need to move, or all sorts of questions come to mind here. So to better understand that, we flew the Lidar around there. And this is what we came out with our GIS analyses here. Is a crown height model comparison between the two data sets. So we took the DSM from 2021 and 2015 and compared it and analyze and quantify and detect how much vegetation was lost, basically. And through that, we can figure out, okay, start to see where is loss and homing in those areas that are lost, without actually going onto the field. And just looking at these things here, the DSM, which the crown height model is produced from, you cannot really actually see any big difference if I compare them. I can see that 2021 and just flip between both of them. 2021 and 2015, you can barely see any difference there. So the crown height model really produces a good picture of how much was lost and how much was gained there. The other case study from Zeballos is fuel load assessment here. And you can see in 2015, this area was just logged with all the logging roads there and some bare, don't really want to say bare, but like it's clear cut, clear of trees, just logged. And through that, we're looking at what kind of fire risk there is here. So again, after the fire hit in 2018, this whole area is just devoid of vegetation because it's all clear cut, right? You can see that rock there is all bare, all that area to the west is clearly burned out, devoid of any vegetation. So what are we looking at here now? Maybe we, again, look at the crown height model comparisons. We can, again, quantify and detect how much vegetation was lost and what does that, and then from there we can actually start to analyze, because there's no trees there, is the slope stable, what's going on there, and what kind of vegetation growth that we need around there, again, to make sure that it's stable. So again, comparing the TSMs from 2015 and 2021, not really too much you can see except for the rocks sticking out there. So the real magic there happens with the CHM, and that's through analyzing our data sets and all that stuff. So the other effort here in Zeballos that we did as well was determining fuel loads assessments. So this is a classic example of after you log an area, there can be waste and residue if it's not burned off, and stuff around there is just lying around, right? And the road there probably constitutes a good fire break, but you can see on both sides of the road there's a lot of dead trees lying around, previously cut trees lying around that could potentially burn off. So if you look at stuff like that, you can run these data sets through algorithms to help quantify and detect these fallen logs. You can determine your rate of burn and all that stuff as well, right? Like just flying a huge data set like that, you can really identify where stuff would burn faster, where stuff would not burn faster, and do we need to clear an area, and determining risks of an area. Is it good to burn? And if you burn too much forest, then all of a sudden your forestry industries, you don't have any more inventory to log and sell, which is a big monetary loss for anyone, and also ecological loss. So our next case study here is from Cameron Lake, and we worked with the BC MOTI on this one very closely. So you can see there that Cameron Lake is there, and this is the Highway 4 is the only paved highway, or road I should say, connecting Parksville, or the larger Vancouver Island, to Port Alberni and Tofino. And Tofino is a huge tourist destination for us. So the fire hit around there in June 2023, early June 2023 last year, and that really closed down the whole highway. So this is our immediate post-wildfire mapping. We were sent there right after the fire was put out. So this is a normal route to get from Duncan, BC into Port Alberni, and it's an hour 45, but because this was closed, because the fire hit right next to the highway and it was not and the slope was not stable, we needed to get eyes up there to determine what was happening. The route to take to Port Alberni, you had to go through, was diverted to the southern route here. And you can see it's an hour longer, but this western side here from Nitnat to Port Alberni is a gravel road, and there are no services around the area. So cars, it's primarily a logging road. So cars were with no fuel couldn't make it all the way through, and there's no cell service. It's not a full service road. If your car broke down there, you couldn't get any sort of emergency services into the area, and it was just chaos. So there was a real need to reopen that road there, that Highway 4, to service Port Alberni and all this stuff, and Tofino. So some little background here. Yeah, it happened in 2023, and the MOT closed the highway. Tofino, Port Alberni cut off, and because it was such a raging fire and there was a need to really put it out before it impacted the larger areas, a lot of water was dumped over the area to douse the fire. So that instantly caused slope stability to be a big concern there. So through that, we'll look at the Lidar products to see why that was. So when our crew got to site there, this is typically what happens when the forest fire hits, and something I don't typically think of. I just think of it as all burned off, but there's a lot of debris around there. So that's pretty much why the road was closed. All the rocks were falling off, the trees were falling off into the road, and it was really, really unstable because when we were on site there, a project manager over there explained to us there's 3 layers of the ground, and usually if a fire hit, the first layer of the ground was forest floor was burned off. It was a big concern, but this one, all 3 layers were burned all the way down to the root of the tree. So it was highly unstable, but we really need to understand why it was unstable there. And through that Lidar helped us just to prevent a lot of locks and to understand which area was not stable at all, so that with the objective of reopening the highway as quickly as possible and as safely as possible. So again, another picture of the ground next to what was really going on. You can see the soil there, and a lot of root was exposed. It's just bare soil. So if it rained or any water was dumped over it, a lot of trees and stuff like that will be pushed down the slope and will end up on the highway, and it could cause major damage. So this was a primary area of interest, the upper bluff, the Angels Rock, and the East Bluff, and they were all sheer rocks going down with not a lot of forest floor left. And this was a pre-fire photo, so you can see there's a lot of dead stuff there already, which constitute our fuel load a little bit. Again, the objectives of the survey: to reopen Highway 4 as quickly as possible, look at slope stability, and assess the layers of the forest floor and check for loose debris. So through that, through our Lidar surveys, we produce a bunch of relief maps here, and you could do water analyses on these to determine how water ran off and how safe they were. So you have to put this into a bunch of other analyses. But through that, you can see where it was steeper and where it's not. Right? And you can see the highway just at the bottom there of the lake. This is another perspective of it. And you can see the steepness of the slope there. So I'd like to point out as well, our systems that flew over this area, it did 70% overlap, and our systems have a lot of returns to take care of the echoing and the LiDAR shadowing of the area as well. Overlap will definitely take care of the LiDAR shadowing. So we really wanted this to be a really dense data set without any shadowing, and because we knew the importance of getting a good layer of ground there, which could penetrate the tree canopy or what was left of it. So this was another result of the fire, and how our data could have helped there. Because of a few areas where we knew that it was unstable, the MOT will set up these 2 cranes 24 hours with operators in them to bring up this big wire mesh to help prevent rocks from spilling onto the road there. The other thing about LiDAR as well, because you fly it, you don't actually have to get boots on the ground, and you can use that to determine if it's safe enough to get fallers up there or anyone up there to assess the slope. Because right after a fire hits, as from the picture earlier on, we didn't know if it was safe enough to send anyone up there, and because there's a lot of rocks and debris coming down, this is a non-invasive way to get eyes into an area to determine the situation. So another case study here was our Lytton fire response, another community that was burnt out in BC. This was primarily for insurance purposes here, and you can see the town burned out there. Another case study here was sorry about that, was determining highway floods around the area. Why does that stop? Yes, going around. But through that so the picture we just saw there, which I some reason keeps skipping over, it's there were some floods that hit the interior of BC in 2021, and we also flew in there to determine slope stability and be able to reopen the roads and all that stuff as well, just to see how much water runoff was there, and making sure that there was a good picture. You can see the highway was cut out there as well. So yeah. So why does LiDAR help in all this stuff here? As I mentioned before with the risk assessments there, and if we just douse the fire and call it a good without understanding there's a real world impact to what's happening up the slope, and reopen the road and not understand there's any sort of slope stability concerns involved, this is an article that showcased what could happen. So you can see a logging road there that services a lot of rural communities in BC. Basically, what happened over here, a boulder fell off a hill and hit a car and killed someone there. And I just cannot help but imagine that potentially there was a culvert up on a logging road that was blocked because of fallen debris from a previous wildfire, or some sort of damming situation involved there. And then finally, when there was too much water that was backed up there, or debris, the pressure caused it to break and a boulder came falling down. So there's stuff like that would really impact slope stability and is a major concern to public safety at large here. So again, why does LiDAR help? The ability to detect higher risk areas with slope concerns and fuel loads before a fire hits, a detection of debris, slope stability, and quantifying leftover material. Also, having a post-fire data set just helps with enabling slope studies, and also determining what kind of risk assessments are in the area, and future proofing an area for planning purposes. And I have definitely come to the end of the presentation here, and can take questions.
Hi, Ken. That was great. Very well done as usual. What I especially liked was your difference in the canopy height model there, where more or less you're mapping, I presume, individual trees that had been either knocked down from the fire or died subsequent to fire, or perhaps even burned up all the way. Um, Very interesting to assess, what the damage was and how much biomass is sort of left. And of course, then the relationship to the slope stability, like you talked about. Is this something you do all the time for forest fires, or is this an evolving kind of method that you folks are working on?
I think with a lot of forest fires hitting in the last 5 years, it's definitely a brought to the forefront in our industry here, where it's it's an evolving methodology, and it's also something where we have to really work with the with communities and agencies involved with their infrastructure into making sure that they have the right data sets and information available to plan for in case a fire happens or what happens after. So
Yeah,
in the last 2 years, definitely we've seen an increase in the number of post wildfire mapping activities here. So
yeah,
yeah.
yeah, for sure. Um, and I think you mentioned it there, but I didn't see it explicitly in your talk. But with respect to, say, mapping of the fuel of for potential for forest fire, um, do you know whether BC or other groups that are more expert in that, how much fuel is there? Are they making use of LIDAR, for example, to understand the number of crowns and the crown density, say, and perhaps understory growth and things like that? My limited knowledge of forest fire work, um, the fuel information is typically one layer, and may not be exploiting the complexities that the lidar can provide us. Any comments on that?
Um, there was a pre-fire survey we did somewhere in California, I think 10 years ago now. And that's another layer of complexity there was we were analyzing rooftop types. So
Oh
from the
yes,
intensity images, so is it clay, is it wood, is it I don't know, some sort of metal or that kind of thing, the
right.
different types of material. And through that, the company we worked with assign a risk percentage to the roof type, and then produce a GIS map of which neighborhoods was more at risk. So that's looking at just purely from the intensity imagery there
Okay.
from the lidar data sets there. So that's a lot of the lidar provides a lot of information, just a point cloud. So yeah, definitely appreciate that question, Tim. Yeah.
Yeah, I mean, a very interesting application, and from what I understand now, I just recently heard that in California, you're not allowed to put up a wooden fence anymore because of the risk of forest fire and so forth. And I presume there's probably regulation coming in with regards to roofing materials and other types of things like siding and so on. Yeah, what a long history of lidar work at Terra Remote Sensing, and I can attest myself that we had Terra come all the way here to Nova Scotia for some of our early experiences with lidar in 2000, then again in 2003 and 2004, and again with helicopter mounted systems. Back then it was the Mark One and Mark Two systems, and produced high quality data as well as very good intensity images, which some systems the intensity can look really good, and others maybe not so much. But your sensors back then, are you folks using a combination of kind of homemade sensors like the Mark systems, as well as commercial, like the Leicas, the Optex, the Regals, these types of things? Or can you talk a little bit about your
Yeah. So we've
technology?
got a few types of helicopter-based systems. we have the E-bears, and we have the Rigels, and we have different types of Rigels. And we don't homemade our own systems or LiDAR units. We piece them all together. So we buy like the CANEX, we've got the Rigels, and we piece them all together in-house to just to give us the best custom-made solution out there in the market, because we realize, the challenging terrain in BC is very challenging it's really mountainous. You got to really make sure the LiDAR is angled well in the unit. Is it 10 degrees? Is it 15? Depending what's the use case for. And through that, we've got a couple of systems that are primarily used for ET work. Some are for forestry work. And we just released this new, or put together this new low-level system. It's two VUX 240s in there with I think phase one camera. So that's really being able to fly lower with higher density and higher resolutions and all that stuff. So that was just put online early last year.
Okay.
I'm still living 2023. But yeah, so we constantly keep up with technology, and we also enjoy piecing these things together. And just to give the market a custom solution and the best LiDAR products that we can put together.
Now you mentioned in the beginning there that you're looking after the drone market. Can you talk a little bit about what technology you're using there, and specifically for LiDAR, or is it photogrammetry, or?
As a company, from our aerial system, whether it's a drone or helicopter, we always collect imagery and LiDAR.
Okay.
Always together. So just so that, in case, it gives us, not just in case, but it gives us a better picture of what's going on there. Because a LiDAR can, even though it's colorized, sometimes you miss stuff. A picture, say an ortho mosaic or a picture, would tell you 1,000 words instantly, right? The LiDAR will provide a further analysis of what's actually going on in the field there. So we collect both. Our UAV stuff is currently LiDAR and photogrammetry only.
Okay.
And we just started commercial operations last year, and looking forward to more commercial operations this year as well. So yeah.
Okay. Well, very good. Somebody made a comment on the Q&A about the great images you were showing. I think especially there where you were showing the bare earth models and how that one particular slope came out so close to the road and obviously caused lots of trouble after the fire with rock falls and so on. So Kenneth, again, great job. I don't think I'm missing any QA questions. That's always a good sign that you've explained your material so well that there's not a lot of questions with that, but we look forward to chatting again during the panel session. So thank you, Kenneth.
Thank you, Tim. We'll see you later.
Okay, bye-bye.